For some unknown reasons, the recording from the last a few lectures, the Zoom always giving me the trouble on this sound effect. Okay, so if you check the canvas, you will find out that I post last year's lectures. Okay, yeah. Otherwise, you won't be able to see. You won't be able to hear the sound correctly. Okay. I hope that the problem has been corrected. I played with the setting on the audio part this morning. Hopefully everything will work just fine. Okay, yeah. All right, okay, so let's get started. Okay, yeah. I hope that you all got a good holiday yesterday. Okay, yeah. I did nothing at home. Okay, just watch some TVs, movies. Okay, yeah, that's all. Okay, yeah. Okay, so let's get start with chapter 2, the application layer. Yeah. And then here will be the outline of this chapter. Section 2.1 talks about the principles of network application. We will start from there. The rest of the section headings, we'll talk about it later. Okay, yeah. All right, okay, so our goal will be get a conceptual implementation aspects of network application protocols, and also we want to know a little bit about the transport layer service models. Okay. And you might be wondering, well, I mean, we are talking about, based on the picture over here, you might be wondering, we are talking about the application layer. Why do we need to care about the transport layer service? Yeah. If you still recall that in one of the maybe sentences in chapter 1, they also mentioned about the kind of the application at each layer will depend on the service provided by the layer below it. Okay, so that's why we will touch a little bit about the transport layer service models. Okay, and then we're going to look into a couple of different paradigms, kind of the connections between two devices, or two programs. One is so-called client-server paradigm, like the World Wide Web. You have a web server, you have a client. So there is the so-called client-server paradigm. But then another paradigm, for two kind of applications running on separate devices to talk to each other, it will be the so-called peer-to-peer paradigm. So if you got a chance to play with maybe the BitTorrent application, it is based on the so-called peer-to-peer paradigm. But then again, in due time, I will give more examples. Another one is the so-called content distribution networks, short for CDN. Again, in due time, they will cover it. Okay, yeah. But then this chapter will mainly cover the client server and then peer-to-peer paradigm. Okay. And then also we'll learn about protocols by examining popular application level protocols, such as the HTTP protocol is the World Wide Web protocol, and also the FTP protocol, file transmission protocol, and then also the email. Email has 3 different types of protocols. One is the simple mail transmission protocol. Another one is the post office protocol version 3. Another one is IMAP. If I remember correctly, I think it's called Internet Message Application Protocol, but I will check on that later. Another one is the Domain Name Service protocol. And also, eventually, we're going to learn how applications talk to each other by learning the so-called circuit programming, like you have been using World Web a lot, right? Almost daily, I assume. You might be wondering, I mean, how does it work, right? How can I just fire up my browser, type in an web address, and then I can connect to our school how they work. So everything under it is through the so-called circuit programming. Okay, so we're going to create a very simple a network application, like a chat program, like a chat program. So again, that will be one of our goals in this chapter. Yeah. All right. So here will be some simple network applications. Email. Then I don't know about you. For me, I use daily because it's, as an instructor, it's my job to check email. At least twice a day. Web or web. Again, if you want to get some data from the internet, you're going to fire up the browser. Texting message from time to time, not necessarily daily. Remote login, there is an application called Security Shield that allow you to log into some remote server as if you sit in front of that computer. So that is called Telnet or Security Shield program. And then peer-to-peer, P2P stands for peer-to-peer. The one, the one this over here, peer-to-peer, peer-to-peer file sharing. BitTorrent is one of the applications using the peer-to-peer file sharing. And then multi-user network games. So I do not play network games a lot, but my son plays a lot. So definitely, he knows these multi-user network games. Streaming, stored video like YouTube, Hulu, Netflix. Right now, there are so many different companies as well. Voice over IP, and Skype is one of the typical example. If you got I don't know if you got this smartphone, right? I'm using the iPhone, so they have this FaceTime to allow me to call or video chat with the other party. And then also some real-time video like Zoom. Zoom. Again, not just limited to Zoom. There are many different type of real-time applications. Social networking apps like Facebook, search like Google, and real-time sports video. They will be good. Maybe watching some games real-time. Right now, the real-time will be US Open, the tennis. You play in daytime as well. Not like football, only play kind of Thursdays, Fridays, Saturday, Sunday. Oh, wow. 3 days a week or 4 days a week. Don't watch too many of them. But unless you got luxury to do so. Audio, I think that my kids use Spotify, right? Spotify. There are other apps for music. Spotify, I think maybe the most common.
There's Amazon Music now.
Oh, Amazon Music. Okay. So you can see that there are so many network applications. So again, here will be the basic idea about how to create a network app. So basically, a network app is a program. As a program like the one we create in the CS1. It's a program. But you need two. In CS1, you just create one application and run it on your a desktop computer or laptop. That's it. But for network applications, you need two programs. Running on one device and then another one running on another device. Can the two programs run on one device? Yes. When you do the testing purpose, yes. But in reality, the two programs, one will be running on one device, another will be running on another device. So again, creating a network application basically will be writing programs. So you can see that this is plural, not singular. running on different end systems. Again, can be a surveillance camera, nothing wrong about it. It is network enabled. And then communication will through the network. Public network, private network, doesn't matter. And then for example, will be like the web server. Basically, the web server is a software, is a program. And then communicate with the browser. So the browser is another program. Again, we call it the client. Through the internet. And then you say, well, how about software? Over here, you say that the program will be running on end devices. So this like, for example, end device. Maybe connect to a web server, or maybe another desktop computer connect to a web server. But then how about the devices in between? Like network routers, switches. You can see that no need to write software for network core devices. No need to do that. Imagine that if those network core devices, you have to write software and install it. Oh wow! Then the IT people will be busy almost 24/7 all the time. Because there are so many updates, so many new applications. Okay. So based on the network architecture, then no need for that. No need to write software for network core devices. Network core devices do not run user applications at all. So that's why you see that for the routers over here, it only provides 3 layers of services. That's it. Network layer, data link layer, physical layer. Here is another group of network routers, 3 layers of services. And then if it close to the edge network, then the switches even provide only 2 layers of services. But end systems, 5 layers of services. So applications on end systems allow for the design like this is to allow applications on end devices for rapid application development and also propagation. So any changes on the application will be transparent to those network core devices. They don't need to know what's going on at all. Okay, possible structures of applications, client server like web browser, and then the web server. Another one will be the peer-to-peer, P2P, short for peer-to-peer, short for P2P, torrent. All right, and then let's start with the client server architecture. So we can see that over some end network, you will have servers, can be web servers, can be email servers, can be different type of servers. But then if we use the World Wide Web, then definitely the end system or end device browser, and then type in the characteristics between servers and client programs. So for server programs, it is always on. It's running 24/7, 365 days a year. It's always on. It's always running. And then also the server has a permanent IP address. You say, Dr. Su, I don't quite get it. What do you mean permanent? So all the computers here, except the printers at the back, it is highly likely that today, you check the IP address, you write it down, maybe it's 10.0.0.5, but then maybe when you shut it down, and then 3 days later, you turn it up again, and then you will get an IP address, but then the IP address could be 10.0.0.20. So which means it changes all the time. So that is the so-called dynamic address. But then for servers, no. For servers, it has to be what? Has to have a permanent IP address. So which means once it got assigned, they may change. Unless it's necessary. Okay, So again, that is the so-called permanent IP address. And also again data centers for scaling. So a lot of times the data centers have these so-called server farms in case that if there's a huge demand, then the web servers will get rotated to do this so-called load balancing, especially during hot seasons like maybe Thanksgiving, Christmas. So again, they would for the scaling purpose, data centers will host those servers. And for our school, definitely we have our own web server, email server. Blackboard gone. I should update it to Canvas. Okay, I should update it to Canvas. But then, can you set up your own web server? Yeah. How long will it take? 5 minutes. You say, you kidding me? 5 minutes set up a web server? Yeah, that's it. Not a big deal. Yes, yeah. But to write a program, yeah, it takes some time. Okay, but then to set one up, pretty straightforward. Yeah. Client so again, clients will communicate with the server, but then maybe intermittently connected. So maybe right now, hey, I want to visit CNN website. I fire up my browser. I try to type in CNN.com, press enter key. Definitely, I can visit the website. But then maybe next minute, oops, battery out of power. So disconnected. Or maybe I purposely turn it off. So again, for client can be on, can be off, can be on and off. So sometimes maybe I got internet connection, maybe not. In addition to that, I may have dynamic address. So again, if I connect to our school's network, then I temporarily got an IP address. But when I go home, I connect to my home network, I got a different IP address. But even within here, within the campus here, within the lab. So sometimes again, your computer might use one IP address, but once you shut it down and maybe wait for a while and reboot it, the IP address might get changed. So there is the so-called dynamic IP address. But in just side note, what devices will use the permanent IP address? Definitely web server, email server, FTP server, along with other type of servers. In addition to that, the one you can relate it to it in here, or in each lab will be what? The network enabled printers. So imagine that if the two printers change IP addresses all the time, it will drive you guys crazy if you need to print a document. MRQ, then you have to go back there to check, hey, what is the IP address right now? And then when you print, you have to use that IP address to send your document to get printed on the printers at the back. So that's why for network enabled printers, it uses permanent IP address. Okay, you can play with it, set it up, no big deal, but it uses permanent IP address. All right, and then also do not communicate directly. So for my computer and your computer, usually we don't talk to each other at all. Because you are not running a web server, or other type of server, so we don't directly talk to each other. For peer-to-peer, so again, no always on servers, arbitrary and the systems directly communication. So you can see that this is an example of peer-to-peer kind of network. So over here, kind of device between devices. Sometimes maybe they are on, sometimes they are off, and then they are again. So that's why it says that arbitrary one connect to this one and this one connect to this one to share files. But it could be this one connect to this one to share file. Or this one connect to this one, and this one connect to this one to share file. And then get from this device. But then again, okay, that's why I say that okay, there is, I mean, arbitrary end systems, but then usually okay, they have some kind of virtually direct connection, okay, direct communication. And peers can request services from other peers, okay, and then provide, okay, but at the same time, it provide services in return to other peers as well, okay. You say, well, can you give an example? Yeah, sure. So maybe get this device over here has a file, get like some get really good audio file, okay, maybe Hold My Hand, you know, Top Gun, you know, you guys watch Top Gun? Is that song called Hold My Hands? No,
I don't.
you don't remember. Anyway, yeah. So soon there's a song called Hold My Hand, right? So okay, but then this device want to get, so maybe this device will connect to this device, and this device connect to this device. Then in that case, okay, this device requests a file okay, from this device, and once you got some of it, then you can get forward it to get this one. Okay. Again, peer-to-peer use get so-called kind of divide the file into chunks. In due time, we'll learn about it. Okay, so no need to store all the files and then forward it to another device. Okay, so in this case, you can see that okay, this one get like a server, but then this one like a client. But when the file to this device, this one like a server, and then this one like a client. Okay, so you can see that this device, okay, or actually each device can play two roles. Okay, as a server and also as a client, depends on the situation. Okay, so that is the nature of this peer-to-peer architecture. Okay, and sales scalability. Okay, so again, some maybe new peer can to join the group. Okay, yeah. So new peer bring a new service capacity as well as new service demands. Okay, so maybe someone want to join the group, the peer group say, hey, I have another song available. Anyone want it? Yeah. So this is the peer-to-peer situation. Peers are intermediately connected IP addresses. So again, sometimes maybe in the middle, downloading the file from here to here to here, and this guy say, hey, sorry, I mean, my class time is up, so I have to go to class. So that device just shut down, just turn off his or her computer. Then what's going to do? No big deal. Again, maybe this device will make a request to another device who can connect to this device. So that's kind of how it works. Okay, yeah. And then of course he has some kind of complex management way of doing it. In due time, we'll study that. And BitTorrent is a very typical example of this type of application. File sharing. All right, and then again, for applications, basically it is a program. But then when it's in execution, we call it a process. A program, if it is not in execution, then it's just a program. But if it is in execution, then we call it a process. So a process is a program running within a whole. You say, I mean, Dr. Su, I don't get it. So let me use this kind of 3-finger salute, Control Alt Delete, to bring up this text manager, okay? And then you can see that, I mean, under the process tab, there are so many apps running as of now, right? But then do you see Microsoft Word application there? No, right? But then Microsoft Word is a program, but it's not running as of now, right? So if I move down on this definition, is a program not running as of now. So it's not a process. But if I fire up the Word, Okay, then it is running now, right? Link file will be. And then you can see that, so now Microsoft Word program is a process because it's running now. Okay, yeah, so that is some concept you have to understand. Okay, yeah. Of course, I can select this one and then end the test. Okay, so I do the process. Yeah. All right, okay, and then again, within sample scale, in two processes communicate using the so-called inter-process communication defined by the operating system. If you got a chance to take operating system, I think Dr. Sandarajan might show you how two processes within the same computer to talk to each other. But in our case, no. In our case, two processes most of the time will reside on different machines or different hosts to talk to each other through the public internet. Okay, yeah. Okay. So processes in different hosts communicate by exchanging messages. All right. Okay. So again, I mentioned it under the client server paradigm. There are two programs running, or two processes running. One is the server process, always on, waiting to be connected. And then it's a process that instantiates communication. Okay, yeah. All right, and then applications with peer-to-peer architectures have client processes and server processes. Okay, so a moment ago I used this example here. Okay, so if this device want to download some file through this device, and then the source is here, then this intermediate one it will act as a server as well as a client. Yeah, yeah. All right. Okay. So in due time, not today, I will talk more about circuit programming. So here will be some term to get to know. Okay, circuit basically processes like circuit allow process to send all the messages to as long as circuit. This is very abstract, I know. Okay, but then think of it like some program allow you to write code to send the data to the other device and also receive data or message from other device. Okay, think of that way. Yeah. So circuit is similar to door. Sending process shows message out of the door, and then sending process relies on transport infrastructure on other side of the door to deliver message to a circuit and the receiving process. Just like, hey, I mean, there's a process running, and if there's a message to send from whatever application, can be email. After you click send, then the message will send out through the circuit, and then the message again will go down through transport layer, network layer, link layer, physical layer, and then travel through the internet. Eventually, I will get to the physical layer of the other device, and then network link layer, network layer, transport layer, and then it will get to the circuit, like a door at another device, and then this circuit will again forward the message to the right process. You might be thinking that why you say right process, because and the device can run in different processes. Game, web server, email server, or even client. Yeah. So again, that is the kind of circuit's job. To deliver the message to the right process. All right. And then again, now we're going to talk about briefly talk about addressing processes. So to receive messages, a process must have identifier. And we all know that a host device has a unique 32-bit IP address based on IP protocol version 4. Okay, yeah, version 6 has, if I remember correctly, 128 bits. Okay, yeah, but then the one we are using right now, 32 version 4, the IP address consists of 32 bits. Okay. Then the question will be: does IP address of host on which process running suffice for identifying the process? The answer is no. Okay, because why? Because many processes, game, email, web browser, different type of apps might be running on the same host. So in order to identify which process will receive the message or send the message, then you need one additional information, which is the what? The port number. Okay, which is the port number. So identifier includes both IP address and the port number associated with a process on the host. An example of port number will be the HTTP protocol is running at port 80, mail server port 25, and then to send HTTP message to, let's say, this web server, then you can use something like this 128.11.245.245.12, and also port number 80. However, you say, well, I mean, I've been using web browser a lot, right? I never type in the port number, because if you are using the HTTP protocol, then if I type in www.se.edu, it will assume, it will assume that the port number you want to visit will be port 80 by default. By default. So let me try the package. So you can see that this is the package web server. Okay, so let me try this one. You can see that do I add any port number after the web server's name? No, not at all. But can I add something to it? Yes. I type in. That means, hey, I want to visit this web server running at port 80. Okay, so let me copy this one. Okay, that port 80 over there. Done. Okay, because again, the web server, if it sees HTTP by default, this server will be running at port 80. Am I sure? Yeah. So you say, well, any other benefits of using this port number? Oh yeah. In case if you want to set up a web server, but allow only certain people to access that web server, then I mean you can pick a different port number, maybe 8080, maybe 800, and then the server running using the port, let's say 800, or maybe 8000. Then when people type in the first one, babbage.se.edu, I guarantee you that it won't work, because your server is not running at the default port number. Again, for security purpose, right? So in that case, then they have to add this column and then 8,000, for example. If your server is running at port 8,000. All right. So again, this is a typical example. And then you can see that the package will have the IP address of the host and also the port number as well. Oh yeah, again, think of port number like our school has this maybe common number like 745 2000. But when you call, then the operator of the machine will say, hey, I mean, what extension you want to connect to? Am I with you? So think of extension like different services provided by maybe music department, math department, computer science department. We all have our own extension number. So think of, but then we all work for the same school. So think of this. Okay, then the application layer protocol defines in general the type of messages exchanged. In general, two types. One is the so-called request, another one is the so-called response message. And then also the protocol also defines the message syntax, which means that, hey, I mean, what fields in the message represent, and then how fields are delineate, which means how fields are separate from one to the next one. And then also message semantics, the meaning of information in each field. And then again, how about the rules? The protocol also defines the rules for when and how processes get sent and response to messages. We will see some simple example in a minute. And then there are so-called open protocols as well as the so-called proprietary protocols. Open protocols usually you can find it in the so-called request for comments. This is a comment website. You can let me see. Let me see whether I can get it. So this is so-called request for comments website. Is I believe is a public domain. Public domain website. Non-profit. And usually you can look into more specific kind of protocol. So you can see that this is the earlier version of the protocol. HTTP protocol. The earlier one will be 1.0. Then later on get 1.1. 1.1. Now we are using 2 point something. And then you will get I mentioned about how messages get talk to each other. I mean, tons of information. And then you say, well, can I create my own web server? Sure. I mean, you can create your own web server. But then you say how? Based on the information in there. You kidding me? No, I'm serious. I'm serious. You can create your own web server. You can create your own browser. Browser, sure, why not? And then as long as you follow the definition here, then your Jump browser can connect to any web server in the world. Whether it's from Microsoft or from Linux or running the Linux web server, Apache web server, or Microsoft IIS or whatever server, it doesn't matter. As long as you follow the definition in there, then you can create a browser, your own browser. And then again, those open protocols allows for interoperability. So they can again, as long as you follow the rule, they can talk to each other, no problem. Like HTTP protocol, the web server, SMTP, simple mail transmission protocol, the email protocol. But then there are proprietary protocols like Skype, so which means that you are not able to see how the protocol interact with the server at all. Those are the so-called proprietary protocol. All right. So in order to then you get a feel of this so-called message syntax. So I'm going to use the one, but then it's better follow some slides okay, from another textbook I used to use. Okay, yeah, so please give credit to the author. Okay, so okay, over here you're going to show okay the package structure. Okay, yeah, the request page package and also the response package. Okay, so let me quickly get fired up my Wireshark. Okay, yeah. So where they go, okay. So this is the software, okay. And then there are a couple of connections really confusing. I just pick the Ethernet, okay. Pick the Ethernet, okay. Pick the Ethernet. And then okay, you can go to okay, capture, okay, and then go to options first, and make sure you pick the right one. The Ethernet one usually will give you the IP address, okay. Yeah, so this is something you can check. But then for other options, you won't see the IP address, okay. Yeah. So make sure you pick this one, okay. I'm not going to start yet, okay, because okay, I have to. Okay, sorry. Because I have to make my browser ready. Okay, yeah. So let me connect to, let's say, my simple get website under package. Okay, yeah. So okay, now the address is ready. Don't press the enter key yet. Okay. So now I have to capture the packages first. Okay. So let me click start. And now let me visit my own website. Hello world means it's very simple thing. Yeah. Really kind of a little bit dry. Okay. Yeah. But I mean this is demonstration. Okay. So now let me start. Okay. Yeah. Start capturing. Okay. And let me see. Okay. Is the IP address of either my machine okay, or the package. Okay. Let me try the package. Okay. I can clean the package. So it's 165.58.120.12. Okay. Set side. Okay. So on. And in the filter box, okay, let me try IP.ab. The R means IP address. Okay. 4164.58.10.12. Okay. All right. Okay. Now then. Let me see. Okay, let me try. Give me a minute. Let me just end this one. Okay. Give me a minute. See what I can set it side by side. Okay. I have to change. Okay, yeah, this is better. So I specify two sub conditions. The first one will be, let me copy this one so you can see it. The first one I say, hey, for the packages you captured, hey, I want to get, I want you to show me only the package you running the HTTP protocol, okay? And also the IP address will be the babbage, yeah, babbage web server can be in the source package, all the destination IP doesn't matter. The source IP address in the package, all destination IP in the package doesn't matter. Okay, yeah. So okay, you can see that it captured one for me. Okay. Let's take a look of the format over here. Okay. So let's see. Yeah. So let's take a look of the format here. Okay. Yeah. Oops, sorry. Yeah. Yeah. Okay. Yeah. This is. So you can see that. Okay. Let me duplicate this one. It's what the other one later. All right. So okay, let me see. Give me a minute. Not the web server. I try to visit. Let me capture another one. Okay. Try again. This is the challenging part of doing a live demo. Start. Then again. Stop. And we do it again. Not bad. The net. Check. It's correct. Start capturing packages. And visit my own website. Stop it. Give me the HTTP protocol only. Yeah, not bad. Yeah, got it this time. All right, so you can see that. Yeah, this is from my machine to the database server. Yeah, so you can check the IP address. Yeah, the IP address of the database server. Okay, yeah. And this is the reply from baby server back to my machine. Okay, yeah. All right. So let me select this one and then expand the package structure over here. And let's take a look of the request message first. All right. Okay. So you can see that the request message over the very top of the PowerPoint over there. The very first one is the request line. Okay, request line. And then followed by header lines we'll talk about it later, followed by blank line, followed by the body. And for the request line, you can see that there are a couple of fields over there. Start with method. And SP stands for followed by a space, followed by URL, which means the web address. Followed by SP space, followed by the version number, followed by CR. CR stands for catch return, followed by LF. LF stands for line feeder. Okay, yeah. So you say, well, how do I find those fields? So if we expand the HTTP protocol, we look at the fields over here. And then let me narrow it down a little bit. So would you please tell me that what is the method from the highlighted over there? Get. So if I get X, say Jack, I mean, what time is it? I make a what? Request, message. I want to get. Am I sure? So that's why, if you look at the right picture over here, it is what? Request message. And the format start with what? Request line, start with get method. And then you say, well, I mean, where is this SP? SP is here. There is a space. Am I sure? I mean, I did not make it up. Okay, yeah. And then followed by what? URL, because I want to visit. The source website. Actually, it's my website. All right. Yeah, so this is the URL module, the URL, followed by space. Oh, there you go. There's a space there, a module, followed by version number. It is what? HTTP protocol 1.1. And then followed by catch return, /r catch return, followed by LF line feeder. New line character, line feeder. About you. So you can see that, then this is the field defined by what? The HTTP protocol. Another type of protocol, they define the fields in the package differently. But for HTTP protocol, this is what's going on. Yeah. And then how about the information under the header line section? Again, can be header name, So you can see that. Next one it is what? Header name is related to a host. So you can see that it is a column there, right? And then header name in this case will be host, and then indicated, hey, which is the web server, all the hosts, machine name, babies.se.edu. Followed by again catch return line feeder. Then this is another header. So this header is called a connect, and then followed by column, right, space, and then keep alive, and then another header, another header, another header, tons of it, and then even got some cookie as well. Another header, and then again followed by catch return blank line. So there is what? Catch return blank line. Am I sure? So we, I mean, as network engineers, or network guy, we need to know what's going on. I mean the details. We are not end users. End users, I mean, you don't need to care about it. But no, we are network engineers. We need to know all the details. All right. So I don't know about you. I mean, it's pretty neat. Right? It's pretty neat. All right. So you can see that again. Get method. But then how about the response? So let me make a duplicate. Okay, so okay, before I do that, okay, you can see that the field structures, okay, field structures among the request message and response message, they are not the same. If you look at the request line, okay, yeah, it starts with method space URL space get version get CRLF. But then for the response message, no. The first line is called status line. It starts with what version number space get status code space phrase get currently return line meter. So let's take a look of the response message get field structure. Okay, yeah. Oops, sorry. Okay. Okay, so okay. But then you say, well, how do you know that the next one is response? So that's why the other day I want you to pay attention to get what the source IP versus get a destination IP. If you remember correctly, yes, I use the envelope example, right? Yeah. For me, will be what? By source IP. And 2 will be destination or baby's get the destination. But if it got swapped, means what? Someone sent the letter to me. So which means someone responds get to my get request. Okay, so that's why you might click the second package over here, then you can see that that is what a response message sent from the baby server back to my machine. Okay, and then now okay, if we look at the package structure, okay, let's check it out. Okay, yeah, let me not distract you using this one. Okay, so you can see that start with what? HTTP get protocol version 1.1. The version number followed by a space. There you go. Get space is there. Followed by status code. Get 304. In due time, okay, we'll cover it. If this is the first time you visit that website, okay, the status code will be 200. Okay, but since I have visited, my browser has visited the website a couple of times already, so it responds 304. Okay, and then usually if this is the first time you visit that website, the phrase related to the slave codes will be good. But since again I have visited that website, my website a couple of times already, so it shows the content did not get modified. Oh, yeah. All right, and then followed by catch return line reader exactly like the stuff over here, and then followed by a group of headlines. Can be 1, can be 2, can be more. So this one headline date, and then the server, it's Apache web server. The connection, keep alive, e-tag. In due time, you will learn about it. Okay, yeah. And then along with last one will be the cancel return. Yeah. And yeah, so let me see. Anything I want to share with you? Yeah, I guess that's it. Yeah, that's it. Let's see. Yeah, since it's not modified, you won't see the content. But what's my point? My point is that is to show you that the protocol define the message syntax, including what fields in messages and how fields are delimited. Moment ago, if fields in the same line delimited by a space, but if in next line delimited by what? Character return and line feeder. Yeah. And then again, message semantics, meaning of information in the fields. Oh, method. we just see get, but then there are other methods called post. Okay, or delete. Yeah. And along with different meaning of those fields. Okay, yeah. And then they're all defined by the protocol. Okay, yeah. And then rules for when and how processes send and response. So again, the server the protocol defined it. Hey, the server is up all the time, but when you receive a request, then you will try to get that file and then send it back to me. Send it back to me. So we again those will be defined by protocol. I mean, I don't know about you. When I play with the Wireshark software, capture some packages, and wow, this is amazing. This is amazing. Almost that anything any packages passing through the network where my computer connect to, I can capture all the packages. And look into the content. And that's why we need you guys to do what? Encryption. Right? People in the school business, they are not going to write code to do encryption. So who is going to do that? You guys are going to do that. All right. So again, there are so many different encryption algorithms. So this is the response message. All right. So a moment ago I mentioned it. Hey, for application running on the application layer, it also depends on the service provided by the layer right below it. Right below it in this case will be the transport layer, not network layer. So it's the transport layer. So what services provided by what services available in the transport layer the application needs. So it really depends on what type of applications you try to create. And then the transport layer, it provides in general two types of services. One is the so-called TCP service, and another is the so-called UDP service. So if your app needs some kind of data integrity, which means that some apps like file transfer or World Wide Web require 100% reliable data transfer, then you would like to use the so-called TCP service. But in other applications, like if you are, creating, let's say, Spotify type application, listen to music. Some bits got lost in the package. Do you care? You don't care at all. Music, right? Or maybe real-time applications. Like watching, let's say, football games. Some bits or packages got lost. Do you care? It really doesn't matter. But if you are doing the online banking, no. Every bit is important. Okay. Receiving $10,000 versus receiving $1,000 is a big deal. You say, why you are so picky? It's one difference under 1 0. That's all. No, it's a big difference. Okay, 1 0 missing is a big deal. Or again, depends on the timing, right? Depends on the timing. So some apps like internet telephony interactive games require low latency to be effective. So in that case, you would like to use the so-called UDP service because it has the less overhead. All right, and then some might be related to your app might concern about the throughput, such as multimedia type applications require minimum amount of throughput to be effective. So again, which means that if you are doing some developing some real-time applications, you would concern about, hey, I mean, in this amount of time, the amount of data should arrive at the client side. Okay, so you will concern about it. Other type of applications, maybe some elastic applications. You want to make use of whatever throughput they get, maybe again real-time sports. And then some other type of applications you might be more concerned about security. A little bit late is fine. But then you want to make sure that the content of the package won't get changed. Or if it got intercept, then no one will be able to look into the content. So encryption involve data integrity. So again, really depends on what our application. So this is the throughput. I believe that in chapter 1 we are looking to the this picture already, so I'm not going to repeat it. Okay, So here is a very good summary, brief summary prepared by author. So if you are developing the file transfer type protocol, does data loss concern you? It concern you. You say no loss of data bit at all. But then how about throughput? Throughput means that, hey, you really care about when you transfer a file, how much time or the amount of kind of bits got transmit to the other side within certain time unit. File transfer protocol, you really don't care that much. I mean, 1 minute is fine. Or maybe 1.5 minutes is fine. Time sensitive, not really. Like email, when you send email, after you click send, you really care about your friend can receive it right away, or maybe 20 seconds later receive it, receive the email. This is not the case, time sensitive for those type of applications. So again, file transfer protocol is not time sensitive, not that time sensitive at all. Email, any data loss can be allowed. No, cannot. Throughput, certain amount of bits received at a certain in a certain time unit, you really don't care that much. Very flexible, time sensitive, not really. Word document, hey, no data bit loss is allowed. Especially online banking, throughput, elastic, time sensitive. It's fine. It's not that sensitive. Real-time audio or video, package loss. Yeah, sure. I'm just listening to music. I'm just watching some football games, tennis games. Some package got lost. I don't mind. But then throughput, hey, in order to make the listening of the audio or watching the video file more smooth, then maybe within let's say 1 second of time, the amount of data transferred to the other party, should fall within this range. For audio, for video, should fall within this range. All right, and then time sensitive, yes, time sensitive. But then for video, within kind of 10 hundredths milliseconds. But then how about stored audio or video file like YouTube videos? Package loss is fine. YouTube, right? But then how about throughput? Same as above. Sensitive, time sensitive, same as above. Interactive games, package loss is fine, but then this is more strict on the throughput, and especially it's very time sensitive. Especially when you play online games. Text messaging, package loss, no. Every bit had to receive. Time sensitive, sure. Maybe within hundreds of milliseconds. But then again, yes and no. Right, okay, so that will be some kind of transport services requirements, for those common apps, okay? Yeah. And then again, a moment ago, I mentioned about TCP and UDP service provide the transport layer. So for TCP, TCP stands for Transmission Control Protocol. It provides a reliable transport of data between sending and receiving process. So which means that if you're going to develop some kind of web application, then the transport layer service, you would like to use what TCP. Yeah. But if you are developing some stored video type applications, you really don't care that much. So in that case, you would like to use what UDP. So UDP service provide unreliable data transfer between sending and receiving processes. Then you might be wondering, then in that case, why people would like to use UDP? Because UDP has very less overhead. When we learn about the TCP protocol, you realize that before application to send data, they have to do this so-called TCP three-way handshaking. They have to set up the connection first before sending the data. But using UDP, who cares? Your application, once the package is ready, boom, 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 you keep shooting out. Is it? Okay, yeah. So it has very less overhead, so it can deliver the packages really fast. All right, and then TCP also provide a flow control, so which means that the sender won't overwhelm the receiver. So example will be like, hey, maybe John is having a supercomputer, really powerful, right? But poor guy like Tabasu is using those old antique computer. So can the John's supercomputer send me let's say 100 packages per second? Yeah, but my computer couldn't handle it. My computer is really old, right? So in that case, if John's computer send me packages so fast, I couldn't handle it. So a lot of packages will get dropped. So in that case, through TCP, before sending the data, the server will ask my computer, say, hey, would you please tell me how many packages can you handle? I say, 5 per second, not 100. Then the server will slow it down. So again, involve overhead, but it makes sure that the sender won't overwhelm the receiver. And also, it provides how much time I have. It also provides congestion control. So if I'm a supercomputer, I'm using a supercomputer, John is using supercomputers, and then John said, hey, you ready? I can send you 100 packages per second. I said, sure, shoot it. Right. But how about if the traffic over the internet is bad? Then again, package, we know that, right? The router, if the buffer is full, the router is going to drop the packages. So in that case, wasting of resources from the sender's computer. So they involve the so-called congestion control. So that is a TCP has a way to what? Slow the server down, the sender down. But then TCP does not provide timing or minimum throughput guarantee or security at all. And it is a so-called connection-oriented connection service, means that before sending the data, there's a setup between server and client process have to be done first. In due time, next time we will see some simple examples. But then for UDP, we know that it does not provide reliable data transfer, but it has less overhead, and it does not provide reliable flow control, congestion control, timing, throughput, guarantee, security, or connection setup. Then again, you might be asking, then why bother why is there UDP? Again, there are needs for that, especially for multimedia applications, sending audio, videos, you don't care about package got lost, but you are more care about the timing, the timing. So I think that that kind of my time is up, so I will stop right now, next time, we'll cover more topics, okay? Yeah. So feel free to stay if you have questions. Otherwise, that will be all for today, okay? Yeah.